Let's continue the study of German vaults through a man named Anton Tedesko. As I said in the beginning of the lecture, he came to the United States and pioneered thin-shell concrete construction. Before I talk about his structures, let me give you a brief bio and introduction to Anton Tedesko. He graduated in 1926 from the Technical Institute in Vienna as a civil engineer. He had European education and practice, meaning he studied completed works, and his practice was a combination of design and construction. In 1930, he joined Dyckerhoff and Widman. This is where Finsterwalder and Dischinger worked, and this is where his thin-shelled concrete practice begins. After the successful completion of several large-scale domes and barrels in Europe, Dyckerhoff and Widman decided to expand their operations to the United States. They sent Tedesko, who had prior experience living and working in the United States, and he sent them over here in 1932. The tradition begins in New York City, the Hayden Planetarium, which was torn down in 1997, but not for structural reasons. It's the first shell that Tedesko worked on in the United States, and perhaps the first full-scale reinforced concrete thin-shell structure in the US. It was a pure dome. The construction of these thin-shell concrete structures involves what's called scaffolding and formwork. Remember, concrete, when you mix it, is in a fluid form, and you need a mold to support it until it hardens. The scaffolding supports the formwork. The formwork is essentially that mold that hardens the concrete into the proper shape. For the construction of this Hayden Planetarium, the formwork was built on scaffolding, and this formwork and scaffolding could not be repeated and reused on this project. It all needed to be built all at once. This process was expensive, and it required intensive labor. The Hershey Park Arena is the first economical Tedesko structure in the United States. Hershey is a famous chocolate brand in the United States, and according to its website, it is, quote, the leading North American manufacturer of quality chocolates. Hershey Chocolates was founded by Milton Hershey, who, according to David Billington, decided to construct a sports arena with the labor of chocolate workers to provide jobs and boost morale during the Depression of the 30s. It was built in 1936 with Anton Tedesko as the designer and builder of the vaulted roof. It's used mostly for ice hockey today, both college and high school, and in the past it was used for basketball and special events as well. As you can see, it's still in good condition today, more than 80 years later. The structure is comprised of a curved slab of reinforced concrete that is 3.5 inches or about 9 centimeters thick. It gets thicker at the supports and at the top. The top of the vault is called the crown, and at this place you have large loads such as speakers and lights. The crown sits about 100 feet or about 30.5 meters above the ice, and the thin shell spans 39 feet 2 inches or about 12 meters between the arches. The shape approximates that of an upper part of a pipe with a radius of 132 feet or 40 meters. The thin slab helps the arches carry some of the load and also provides lateral support for the arches against buckling. The arches are 22 inches wide by 60 inches deep, approximately 56 centimeters by 152 centimeters. At the supports, the arch depth increases and sits on hinges to allow free rotation. The depth of the arch is reduced at the crown at the very top so that it approximates a 3-hinged arch behavior. The arch spans 222 feet, approximately 68 meters, and rises 81 feet or 25 meters above the hinge supports. The scaffolding was reused many times in this structure, which led to the economy. It looks expensive, but it wasn't, because it could be reused for every segment, meaning every slice of the building. The roof was built in 5 segments separated by 4 expansion joints. The 3 center segments were 78 feet long, 24 meters approximately, and the 2 end segments were 52 feet long or 16 meters. Here's Tedesko examining some wires that inform the construction procedure. Each wire is connected to a jack in a specific location in the scaffolding. When the concrete hardens, it's then time to lower those forms, and you have to lower them very carefully. This process of lowering is called decentering. You have to lower these in a calculated way very carefully, because if you don't do it correctly and evenly, the vault might bend and might break. The calculations for the construction procedure are very important, and Tedesko emphasizes that these structures can be economical only if you consider construction carefully. In addition, Tedesko designed many warehouses that were built around the time of the war. He needed to make an assumption in the calculations of the warehouses that the ends of the thin shell are rigid, and these ribs, as shown in the warehouse in Columbus, force that rigid boundary condition that was assumed in the mathematics. The equations had an immense influence on design, and this is a mathematically driven form. Tedesko didn't like to rely on these heavy ribs. It made the project more expensive, and it also made the appearance more bulky. So he carried out a series of experiments. Here's a test that he organized in 1950. These are barrel shells, and he loaded it with people to demonstrate its strength. Here you see that he did away with the ribs and showed that it could indeed work. He also performed some simple mathematical calculations. In this warehouse in Middletown, Pennsylvania in 1959, we have a pure shell with a slight thickening over the supports, but you see that there are no ribs. He removes this rigid mathematical influence on form, but uses experiments as justification. This is simpler and more economic. In addition to warehouses, Tedesko found a market for hangars in the United States. He arrived in this country at a time when air transportation grew rapidly and a large number of hangars were needed. This hangar in San Diego was designed by Tedesko, and you can see that it has a heavy appearance because it was based on the theory of rigid boundary conditions. In this hangar in Maine, the arches are more slender than they were in the previous design. One can see the scaffolding used for construction in the background, which follows a similar procedure that he used for the Hershey Park Arena. For all vaulted structures, the form is the most important parameter. If one has the wrong form, at best, the vault will be expensive to build and maintain, and at worst, it can collapse. Next, we'll examine what I mean by proper form.